This is an installation in an empty warehouse that is going to be refurbished, and my job is to compile a report on the existing installation with presumably the purpose of retaining as much of it as possible and minimizing the cost of refurbishment. Much of the installation is dead. I've got to investigate why it's dead and see where it's dead for a very good reason. This is a Crabtree C50 circuit breaker board, and there are this is service 400 amp TNCS. Just around the side here is the service earthing terminal. Just over to my right here is power factor correction equipment. At the moment it's switched off. I'm not quite sure why, but its equipment is rather crudely marked as the main fuse switch. Whether that is so or not, I'll have to determine by taking the trunking lid off. It's Proteus, which is bad news, and underneath is a buzz bar chamber, the main buzz bar chamber. These various disconnectors are marked up as feeding isolators, which are numbers. High bay, high pressure sodium vapor lamps, and around the side is a run of trunking that's being quite damaged. This is a 15 amp fuse switch. It's switched off. We'll have a look inside in a moment. I don't know what its purpose is at the moment. I think it's feeding another fuse switch by the looks of it. So we have a fuse switch feeding a fuse switch. Just here, I don't know. We have superficially what appears to be a service, but I'm wondering whether in fact that's just a spreader box for a cable. There's no presence of a meter here, although we appear to have just here a CT chamber, a Ryfield CT chamber, but there's no meter here. Connecting directly to that CT chamber, we have this piece of equipment, which is called a panel board, panel distribution board, and it's fitted with molded case circuit breakers. This is a molded case circuit breaker, and this particular one is a 250 amp. It has both adjustable resistive and magnetic settings. The resistive settings are overload, the magnetic settings are short circuit, and at the moment it's set for overload at ×1, in other words it's a 250 amp breaker, and the magnetic settings are on ×10, so it will trip instantaneously at 10 times 250, which is 2,500 amps. That's the main MCCB, and here are the circuit MCBs, distribution circuits, presumably feeding distribution boards. These lower ones are single phase. They're not adjustable in any way. Just here is a power factor correction equipment, item power factor correction equipment. It appears to be switched off or disconnected. Damaged trunking, and also the lid missing, which is very common in this place. Mineral insulated cables hanging down. Something must be done about that. Somebody's stuck some hardboard up there. Is there a trunking lid? Many of these disconnectors, labelled up isolators, are doing nothing. Presumably at one point in their life they supplied the machine, but now they're doing nothing. And the underside indicates that at one point there was a conduit coming out the bottom, so they're actually doing nothing at the moment. Smashed up three-phase switch. At the moment it's dead, but that doesn't mean it can't be energised simply by throwing a switch, so quite dangerous. Underneath it is a lash-up connection to 30 the socket. Interior of the busbar chamber, which is live and heavily used. These cables here, they feed, that's these, they feed the fuse switch we were just looking at, the load side of which is simply sawn off, armoured cable sawn off and just left lying around. So those fuses have got to come out of that fuse switch. To switch it on would be extremely dangerous, and there's no indication by notice or by locking off that you mustn't do that. Bus bars here are the feed to the busbar chamber, and that confirms that this is in fact the main switch. That connects via that trunking onto service. These fuses will have to come out when the switch is closed, and if it were switched on, it would be switching onto a short circuit. They are 250 amps, HBC fuses, BS88 type GG. This fuse switch is serving no purpose and it should be removed. Right, this is a test of phase earth loop impedance, and the impedance that I've just measured at this busbar chamber is 0.08. So at 240 volts, 0.08 into 240 goes 3 kA. Doubling it up because it's three phase, that's 6 kA. This is a test of insulation resistance, and the test being conducted is a test between the between line 1 and earth. Prior to the test being conducted, it was necessary to release the neutral link that joins the incoming neutral to the distribution board. Without that link being removed, you would get false short circuits indicated on your instrument. The reading at the moment is out of range, which indicates it's greater than 200 megohms. This test would be repeated for all three phases. This distribution board is fitted with Crabtree C50 circuit breakers. These circuit breakers are of an obsolete pattern. They are at least 20 years old, maybe older. The circuit breaker physical size is larger than that of the current range, and these circuit breakers work on a principle called magnetic hydraulic. They produce a time delay without the resistive thermo metal that you've got in the current range of BS 60898 or 3871 circuit breakers. This is the main switch, and this is live at 415 volts.